they asked to solve this equation, and it's 11 plus 3x minus 7 equals 6x plus 5 minus 3x.
I'll take this one, I guess.
Okay.
So I've got, I just wrote the equation down that Lily mentioned on my screen. So here's our equation. In an equation like this, one of the things that we would typically almost always want to do as a first step, if at all possible, is simplify, meaning let's make this the easiest equation that we can before we start really working with it. So Nate was talking earlier about combining like terms, and that's one of the things that we can do to simplify. When it comes to combining like terms, we have to keep each side of our equation separate. So on the right side of the equation, I can see 6x and negative 3x. Now I can't combine those with anything on the other side of the equation. It's kind of a common error I see if that happens. So those two are like terms. Another set of like terms that I notice is 11 and negative 7. And I couldn't combine that with the 5 on the right side of the equation because they're separated by that equal sign. So that's going to be our first step, just to keep things simple. So the 11 and the negative 7, that together is going to give me 4. So I have 4 plus 3x on the left. And then on the right side of the equation, I can combine the 6x and negative 3x. So 6 minus 3 is going to give me 3. So I have my equation simplified. So that's all, typically your first step. That can also include distribution if you have any distributing to do. The second thing is, so our goal when we solve equations is to isolate our variable, get it by itself. But what you might notice here is that we actually have two, it's the same variable, but it's on two different sides of the equation. So what might be helpful is to get all of our variables to one side of the equation. Now it doesn't really matter which side, but just to collect them together would be helpful. So I'm looking at this 3x on the right-hand side, and I'm going to move it to the left side by subtracting it. And what you might notice is it actually, on both sides of our equation, our variables cancel. Typically at this step, if this happens, a lot of times I'll have students and they'll say, they'll think they did something wrong at this point. This kind of throws them off because we don't typically cancel on both sides. We're really just trying to cancel on one side, but sometimes this could happen. So I'm going to write the equation out with what we actually have left, and we have this weird equation that says 4 equals 5. When this happens, when your variables cancel, or you're solving and you're left with no variables, there are two possibilities. One possibility is infinite solutions, meaning it doesn't matter what x is, that equation is always going to be true. If you made x 5, the equation would be true. If we made it 1,000,000, it would be true. It doesn't matter what we made x, the equation would be true. That's for infinite solutions. The other option is no solution. And what that is meaning is that it doesn't matter at all what x is. Doesn't matter. It's never going to make that equation true. So at this point, when our variables cancel, we're going to be looking at what's left to help us to decide which of these two options is the case. Could x be anything or could x be nothing? And when you decide this, what you're really trying to decide is this equation true without my x's or without my variables? And well, does 4 equal 5? No, it doesn't. It never equals 5. So it doesn't matter essentially what our variable is. This equation will never ever be true. And so therefore what we would say is there's no solution to this equation. If we had something left when our variables canceled like this on the bottom right that I put on the screen, 4 equals 4, well, yeah, that's true, and that's always true. So if we had something like that, then we would say infinite solutions, but we don't have a true equation, so we have to go for it and say that there is no solution to this equation. So hopefully that helps. Those situations, they do happen every now and then. Not often, but they do happen, and it doesn't mean you did something wrong. Just know how to interpret your answer when you do the steps.
Subscribe!
Come on, push the button.
You know you want to.
Do it.